Hi, Integrated Math 1. Welcome to lesson 2.4.2C. We're on the last chunk of this lesson. There's going to be a lot going on today, so just keep an eye out for that. We are doing activity 2.3, and we're also going to be doing the talk. So we don't really have much that's new going on. You know how to find the height and perimeter of a triangle, right? You know you find the perimeter by adding up all the sides. You know that you find the area by doing base times height and cutting that in half. The problem is we're going to have some funky triangles. And so we're going to have to use some old information that we know how to do and just start putting things together in order to make this happen. So we're taking a look at triangle XYZ, and it has vertices at 2, 5, 10, 9, and at 6, 1. Now, first step isn't that bad. In fact, let me put it here. I know you guys have it on your page, but I turned the page and now I can't see things, right? So we said that point X was at 2, 5. We said that Y was at 10, 9. And we said that Z was at 6, 1. So the first thing I'd like you to do is go ahead and find the perimeter of triangle XYZ. Don't forget, it does say to round your answer to the nearest hundredth if necessary, so 2 digits behind the decimal. So go ahead, bust out distance formula. You're going to have to do it 3 times. And once you find the lengths of all the sides using distance formula, then find your perimeter. Go ahead and hit pause to work this out, and then hit play when you're ready to check your work. So let's do some distance formula. Let's find side XY. So I'm going to subtract my X's, 2 minus 10. And then I'm also going to subtract my Y's, 5 minus 9. And we'll work it out from there. Of course, 2 minus 10 is 8, negative 8, I should say. And 5 minus 9 is a negative 4. We know a negative 8 squared is a positive 64, right? Negative 8 times negative 8. And a negative 4 squared is a positive 16. 64 plus 16 gives me the square root of 80. And I used my calculator. I got about 8.94. Let's go ahead and find side YZ. So again, I'm going to subtract my X's here, 10 minus 6, and I'll subtract my Y's, in this case, 9 minus 1. And that's not too bad. 10 minus 6 gives us a positive 4. 9 minus 1 gives us, that should say 8. Sorry. Gives us 8 squared. And so, of course, 4 squared is 16. 8 squared is 64. 16 plus 64 is a square root of 80, which we already know from our work earlier. It's about 8.94. Ooh, that means I have an isosceles triangle, don't I? 2 congruent sides? Yeah. And of course, we need to find that third side, right? We need to find XZ. So we'll subtract our X's, 2 minus 6. We'll subtract our Y's, 5 minus 1. 2 minus 6 is a negative 4. 5 minus 1 is a positive 4. Negative 4 squared is a positive 16, and 4 squared is 16. Add those together to get 32, the square root of which is about 5.66. So I'm just going to take these 3 to find the perimeter. I'm just going to add them all up. I went ahead and put the square roots back in because I didn't want to round early. You know how it goes. You round early, things end badly. So I actually used my calculator to do the square root of 80 plus the square root of 80 plus the square root of 32. And I got about 23.55, rounding to the nearest hundredth, 2 digits behind the decimal. That's not so bad, right? I mean, we had to use some distance formula, but these weren't too terrible. The negatives weren't that awful, mainly because there weren't any negatives on my coordinates. And so this actually wasn't that bad. But what if we need to determine the area? This gets trickier, right? Remember that to determine the area, you're going to need to determine the height. I don't have a height right now. We talked about this last time, right? We talked about this in the last lesson, how your height is supposed to be perpendicular to your base. So I don't have a height right now. How will determining the height of this triangle be different from when we determined the height of our triangles in activity 2.2 in the last lesson? Hit pause, jot down why you think this is going to be a little different, and then hit play when you're ready to keep the discussion going. So the last time when we did this, at least one of the sides of my triangle was horizontal, which made it nice and easy to use that as a base. This triangle does not have a base that's a horizontal line segment, right? I don't have any like just boring flat lines. They're all tilted one way or the other. Everything's tilted. And so we're going to have to use the slope formula. We're going to have to play with some slopes a little bit to figure out the height for a given base. So I'm going to explain to you how that works, and then we're going to work it out ourselves a couple times, okay? So let's say that we want to use XY as the base. So I want this side right here. I want this bad boy to be my base of triangle XYZ. So I can draw ZW to represent the height. I'll just pick, I'm going to call whatever point, wherever my height hits this, I'm just going to call it W. Now you have to remember that the height is perpendicular to the base. It should make a right angle. So we need to figure out where W is, don't we? To determine the height, the length of our height, we need to figure out where point W is. We need to locate point W. And it's somewhere on the intersection of our base and our height, right? So the big trick, the first thing we've got to do is we've got to figure out where point W is. We've got to figure out where my height is going to hit my base. So you have a worked out example in your book, and we're going to talk about this. We're going to work this out. So the first thing we did is we calculated the slope of XW, right? We said that X was at 2.5. We said that Y was at 10.9. And so they use the slope formula, subtract the Y, subtract the X's. But you also could have used some of our tricks from earlier where we just counted. We counted our rise over run. It is sitting on a graph after all. So either way of doing that is fine. So 2.5 here. So it looks like we have to go up 1, 2, 3, 4. We rise 4, and then we're going to run 1, 2, 3, 4, 5, 6, 7, 8. So it looks like we rose 4 and we ran 8. So that means, don't forget the slope is rise over run. So that means, sorry for the bad handwriting. So that means my slope is 4 over 8, which of course simplifies down to 1/2. So that's what they did here. They just subtracted the Y coordinates to get the rise and subtracted the X coordinates to get the run. We just counted it on the graph, and that's okay. So here's what this means. Remember that in order to be perpendicular, I'm going to erase this, it's distracting. Remember that in order to be perpendicular, your slopes need to be opposite reciprocals. So if the slope of my base is 1/2, is a positive 1/2, then the slope of my height needs to be a negative 2 over 1, also known as negative 2. All right, we've got our new slope. The problem is, I need to figure out where the points are. We got to know where the points are, right? That's the problem. But if you recall from last semester, again, it's been a while since we've done this. We said that you could write an equation, right? You can write an equation for the line using a point and a slope. So we're going to use this point. We're going to use point X at 2.5. And we said that the slope of XY, we said that its slope was 1/2. So we're going to use those. Remember our slope formula, right? Remember how we could write an equation doing Y minus the Y coordinate equals my slope times X minus the X coordinate. So fine. My Y coordinate is 5. So Y minus 5 equals my slope, which is 1/2, times X minus my X coordinate, and my X coordinate is 2. And then at this point, we just cleaned up. So I distributed the 1/2. So that gives me 1/2 X, and half of 2 is 1. And then we add 5 to both sides, and we get Y equals 1/2 X, negative 1 plus 5 is a positive 4. Now we're going to do the exact same thing to figure out our height. We're going to do this to figure out our height. We know what point Z is. We know Z is at 6.1. So there's my point, right? There's my point, Z 6.1. We just said the slope for the height should be a -2. So there's this guy right here. And now we're going to plug in my x coordinate, my y coordinate. So y minus my y coordinate, y minus 1, equals my slope, -2, times x minus my x coordinate. My x coordinate is 6. Again, I'm going to distribute. Oopsie, sorry about that. -2 times x is a -2x. -2 times a -6 is a +12. And again, we'll add 1 on both sides to get the y, all alone on his own. We get y equals -2x. 12 plus 1 makes that a +13. So here I have 2 equations. Now, let's take it back. There's a lot of old stuff going on here. Let's take it back to our last unit when we solved systems of equations. So I see that I have, I'm going to use another color here, see if I can make that a little easier for you. So I see that I have y equals 1/2 x, and I have y equals -2/3 plus 13. So this means everywhere I see a y, I can substitute 1/2 x plus 4. So instead of y equals -2x plus 13, we can say 1/2 x plus 4 equals -2x plus 13. So that's what they did. 1/2 x plus 4 equals -2x plus 13. Yay us. And now it's a matter of working it out. They did it as fractions. I'm not going to lie. I would have done this as a decimal. So I would have changed that 1/2 into a 0.5x. Just because you guys seem to work better with decimals than fractions. If you want to leave it as a fraction, that's okay. I won't tell you no. I'm going to go ahead and add 2x to both sides because I don't want x's on both sides, right? And so that means I have 2.5x. Still the plus 4, it's still equal to 13. I'm going to go ahead and subtract 4 from both sides. And I have 2.5x equals 13 minus 4. Where's my calculator? There it is. 13 minus 4 is 9. I don't need the calculator for that part, but I'm about to need it. And I'll go ahead and divide both sides by 2.5 to get it all alone. 2. So 9 divided by 2.5 gives me 3.6. Now again, they wrote it as a fraction, but if you check on your calculator, you will find that 18 divided by 5 is 3.6. Look at our skills. It's amazing. I have the x coordinate, good, but if I want the point, I need to find the y coordinate. So let's take this x equals 3.6, and let's go ahead and plug it in for x so that we can figure out what y is. So y equals -2. Instead of an x, we'll put in our 3.6 from earlier. Still have that plus 13, and this is also why I have a calculator. So 3.6 times a -2. That gives me -7.2. And of course, I will add 13 to that. And I find that my y coordinate is 5.8. Now again, they left it as a fraction, but if you use your calculator, you'll find that 29 divided by 5 is 5.8. You have found where W is. Here's the x coordinate, here's the y coordinate. So W is going to be at 3.6, 5.8. That is your coordinates for W. You can put that on a graph, right? I'm going to go over 3 and a bit more, a little more than halfway. I'm going to go up 5 and not quite to 6, but I'm going to get awful close to it. And we'll put it on there. That's number 3, right? So we said W was at, hang on, I'm going to make a little note of it. Said W was at 3.6 and 5.8. So we're going to go ahead. We'll go over 3 plus about a little more than halfway. We'll go up 5 and almost to 6. Not quite to 6, but awful close. And look at that. There's point W. Ooh. Now we can draw ZW to represent that height. Yeah. Woo! That was a bit of work. Here, that's prettier, huh? See, I did it all pretty like that. Yeah. All right. We have W. We have we can see the height now. All right, so now that you have W, Here's what you're going to do. Figure out what that height is. That's your next step, all right? We said that W was at 3.6, 5.8. We already knew that Z, right? We already knew that Z was sitting at 6.1. Use some distance formula and find the height of your triangle. Hit pause. Do that distance formula. Find the height of your triangle, and then hit play when you're ready to check your work. All right, distance formula it shall be. So don't forget, we're going to subtract our x coordinates, 3.6 minus 6, and we're going to subtract our y coordinates, 5.8 minus 1, or it looks like I did them the other way around here. We have said before, it doesn't matter which way. We'll subtract our x coordinates, 6 minus 3.6, subtract our y coordinates, 1 minus 5.8. I totally use my calculator. Of course, I use my calculator to help me out. So when I did 6 minus 3.6, I got 2.4. And then 1 minus 5.8, I got a negative 4.8. I used my calculator to help me do the squares. 2.4 squared is 5.76. And a negative 4.8 squared is a positive 23.04. Remember, negative times a negative will give us a positive. I went ahead and I added these together and I got 28.8. And then, of course, I did the square root with my calculator and I got about 5.37. So, yay, I have the height of my triangle. Yeah. You know what's interesting, though? You know what's interesting? I'm just going to say it. You have the height of your triangle. You just found it. But you know what? Earlier on, when we were finding the perimeter, didn't we also find the base of our triangle? Like we found XY earlier, right? That was one of the very first things we did. So now that you know the length of the base, now that you know the length of the height, go ahead and find the area of the triangle. Hit pause, work this out, and hit play when you're ready to check your work. All right, so I flipped back. Over on my page. You probably didn't have to flip as far as I did, but I had to flip over a little bit, a couple pages there. And I remembered that we found XY, right? We found our base, that it was the square root of 80, also known as 8.94. And of course, we just found our height. Like we just found our height, ZW. And we found that it was a square root of 28.8, which is about 5.37. For the purposes of multiplication, and because I don't want to round early, I'm going to leave them in square root form when I put them in my calculator. So remember, you find the area of a triangle by multiplying base times height and then cutting that in half. So I used my calculator, and here's what's interesting. Because I used my calculator and I was like 80 square root times 28.8 square root. And then I divided that by 2. I got exactly 74. Wow. After all these times, I had to keep estimating, and suddenly I got like an absolutely perfect answer without any rounding. Fine, be that way, Mr. Calculator. I see how it is. All right. Now, you know that any side of a triangle can be thought of as the base, right? Like we picked XY. It doesn't have to be XY. I would like you to predict whether using a different side as the base, maybe using XZ, maybe using YZ. Predict whether using a different side as the base will result in a different area of the triangle, and just explain your thinking on this. Go ahead and hit pause, jot down your thoughts, hit play to keep the discussion going. Guys, the triangle itself didn't change. I can pick a different base. It's not going to change the same shape and size of my triangle if I pick a different base. So no, I don't think using a different side as the base is going to actually matter, because the size and the shape of the triangle do not change. So here's the thing here's what I'm thinking. We used XY as our base, and it felt kind of awkward, right? It felt kind of awkward. So let's do triangle XYZ again, only this time, let's consider XZ as our base? What if this is our base? Maybe it'll be a little easier to work with. Who can say? So we're going to have to find that height again, right? If xz is our base, we need to find a new height because I've changed the base. So the height is now going to come from y and it's going to smack into xz somewhere. And we're going to call wherever that point is that it hits into it, we're going to call that point B. And that'll be the intersection of our height and our base, all right? So first thing you've got to do is figure out where point B is. Where does your height intersect with your base? You might want to take a look at what we did before and see if you can figure this out. Hit pause, play with it a little bit, show some work, show your work, and of course, hit play when you're ready to check your work. So let's figure this out. So first of all, I need to know this guy's slope, right? I need to know the slope here. So let's talk slope. It looks like I have to go down this time. 1, 2, 3, 4. It looks like I have to go down 4. And then I'm going to go 1, 2, 3, 4 to the right. And of course, -4 divided by 4 is a -1. So it looks like the slope of xz is -1. Now, we said the height's perpendicular to it. So that means that the slope of my height, the slope of yv, so his slope needs to be the opposite reciprocal. So that means I got to change from negative to positive and I got to flip it. Well, 4/4, if I flip it, is still 4/4. So that means this is going to be a +1. Yeah, so the slope of xz, the slope of my base is a -1, but the slope of my height is going to be a +1. Now, we also said we could write an equation given a point and a slope. So we know x is at 2, 5. We know the slope of that base is -1. So I'm going to use those to write my equation. Remember, y minus the y coordinate equals my slope times x minus the x coordinate. So fine, this is my x coordinate, this is my y coordinate. So y minus 5 equals m, which is my slope, -1, times x minus my x coordinate, which is a 2. And again, I'm just going to distribute. So that makes that a -x. -1 times x is -x, and -1 times -2 is a +2. We'll go ahead and we'll get y alone. We'll add 5 to both sides. Ooh, so those cancel out. So I actually have y equals -x plus 7. All right, let's now find the equation for our height. Well, I know that y is at 10, 9. So there's a point. I know the slope of my height should be 1. So we're going to use those. And again, we're just going to plug them into our formula. So it's my x coordinate, my y coordinate, my m. So y minus 9 equals 1. 1 times x minus 10. Again, we will distribute. So 1 times x is 1x. 1 times a -4 is just x. 1 times a -10 is just a -10. And then we'll go ahead and we'll add 9 to both sides. So that cancels out, gets the y alone. So we have y equals x, -10 plus 9 is a -1. Now again, this means that everywhere I see a y, I can substitute in -x plus 7. So everywhere I see a y, I can plug that in. So that's what I did. So instead of y equals x minus 1, I said -x plus 7 equals x minus 1. And then this really wasn't so bad. I went ahead and I don't like x's on both sides. So I'm going to add x. That cancels out. X plus x is 2x. Great. Let's get that alone. So let's add 1 to both sides. Add 1. So those cancel out. That's good. So we have 8 equals 2x. And of course, we'll divide both sides by 2. Sorry for the bad handwriting. So x equals 4. Oh, and it got all in the way. Boo. That got in. Oh, that's not what I wanted. I'm hitting word buttons. Come here, little eraser. There you are. I'll erase that so it's easier to see. All right, so x equals 4. So I'm just going to take this lovely 4 that we found, and it is a lovely 4. I'm going to take this lovely 4 that we found and substitute in for x. So y equals 4 minus 1. And of course, 4 minus 1 is 3. So it looks like point V is sitting at the point 4, 3. That's a lot easier than the last one, right? So this means, I'm going to use another color here. This means that point V is at 4, 3. So it's right there. Boom, boom. There's my height. Oh, yeah. You know what I'm about to ask you to do, right? You know what I'm about to ask you to do, right? You know what I'm about to ask you to do. Now that you've figured out where V is, I would like you to figure out what your height is. So now that you know where V is, we know it's at 4, 3, right? We know V is at 4, 3. That's its thing. It's at 4, 3. We know Y is at 10, 9. We've known that from the start. Figure out your height. Use some distance formula. Go ahead and hit pause to work that out. And then hit play when you're ready to check your work. All right. Let's see if we can do this. We're going to subtract our x coordinates, 10 minus 4. We're going to subtract our y coordinates, 9 minus 3. And if I do 10 minus 4, I get 6. 9 minus 3 also gives me 6. That's convenient. 6 squared is 36. 36 plus 36 is 72. The square root of which is about 8.49. Now, if you recall earlier, you already found the length of YZ. You already found this length, right? You already know what your base is. You already found it. You also just found your height, didn't you? So now's the time. This is the nice part. Find the area of triangle XYZ. Go ahead and hit pause, work that out, hit play when you're ready to check your work. So I flipped over and I had to go back. I had to go back and look at my work from earlier. I flipped over and I remembered, I found it. We found XZ. We said XZ was a square root of 32, which is about 5.66. Of course, we just found our height, YV, as being the square root of 72, or about 8.49. So great, I got a base. I got a height. I'm going to multiply and divide by 2. Oh, look, I got 24 again. Which should not be a surprise to us. We already knew the area was 24, and we already said the area wasn't going to change just because I picked a different base. Which means you already know the answer to number 7, right? You already know the answer to number 7. Triangle XYZ is graphed on the coordinate plane. Now it's asking us to determine the area of triangle XYZ if we now use YZ as a base. Yep, we're going to use YZ as a base. So one more time. You already know the answer is 24. You already know the answer is 24. We already know the area is 24. But now I want you to go ahead and do this whole game all over again. Find the point here that's going to make this your height. That's the first thing, right? Then once you find that point, use distance formula to get the height. Then once you've done that, use your base and your height to find your area. This might take you a little bit, and that's okay. Go ahead and hit pause and then hit play when you're ready to check your work. First things first, man. What's the slope of this bad boy? So I did a little bit of counting out here, and I was like, okay, looks like I had to go. I'm counting here. So it looks like I had to go up from here to here. I had to go up 1, 2, 3, 4, 5, 6, 7, 8. I had to go up 8, and then I went right 4. So rise over run means that my slope is 8 over 4, which simplifies down to 2, right? 8 divided by 4. Don't forget that the slope for your height needs to be the opposite reciprocal. So I have to flip my 2. So instead of 2, it's going to be 1 over 2. And I need to change the sign. Since this is positive, the slope of my height should be negative. Now I'm going to call this magic point that we hit, I'm calling it U. You might have called it something else. You might have done so, but I'm using U. Hey! So I know the slope of my height should be -1/2. All right. So let's use what we got. We know that y is at 10, 9. We know that the slope of that base should be 2. By the way, you could have used z if you wanted to instead. I'm just using y because I can. So we're going to do y minus my y coordinate, so 10y minus 9, equals my slope 2 times x minus my x coordinate, which is 10. And then we'll distribute. 2 times x is 2x. 2 times a -10 is -20. And then I will add 9 to both sides. -20 plus 9 is a -11. Let's do this again, only now we need to do it for our height. So I'm going to use point x. We already know point x is at 2, 5. So I'm going to use that point 2, 5. And I know the slope of my height should be -1/2. So find y minus my y coordinate, so y minus 5, equals my slope, -1/2, times x minus my x coordinate, which is 2, so x minus 2. All right, let's do this thing. Again, we will distribute. -1/2 times x is -1/2 x. -1/2 times a -2 is a +1. Oh, and we should add 5 to both sides. 1 plus 5 is 6. Hey. Now my y is alone. And once again, I know that if I see y equals, that means everywhere I see a y, I can substitute it with 2x minus 11. So that's what I'm going to do. So instead of y equals -1/2 x plus 6, it's going to be 2x minus 11 equals -1/2 x plus 6. And to make this easier, I rewrote my -1/2 as a decimal as a -0.5. You didn't have to do that, but I thought it would be easier to do. So I'm going to go ahead. I want my x's on both to be on the same side. So I'm going to add 0.5x to both sides, which means I now have a 2.5x. I'm going to get rid of that 11 by adding 11 to both sides. 6 plus 11 is 17. And then, of course, I will divide by 2.5, and that's why I have a calculator, and I got 6.8. Beautiful. So that means I need to plug that x back into one of these equations. You know what? I'm going to plug it back into this equation. So I'm going to take that 6.8. I'm going to plug it in right there. I don't want to deal with the fraction. So y equals 2 times 6.8 minus 11. 2 times 6.8 is 13.6. If I subtract 11, I get 2.6. So it looks like point U, or whatever you decided to call it, is at 6.8, 2.6. So I'm going to go right 6, not quite to 7, and I'm going to go up 2 plus a little more than a half, something like that, and I'm going to draw in my height. There's point U. There's my height. Almost there. All right, so this is the worst. This is the worst. The worst is over. Now, did you use distance formula? Did you use distance formula, right? Because you're like, okay, well, this is 2, 5, oopsie, and this was, what did we say? 6.8, Miss Scott can't write, 6.8 and 2.6, right? Let's do distance formula. Subtract my x's, 2 minus 6.8. Subtract my y's, 5 minus 2.6. I used a calculator. So 2 minus 6.8 is -2.6. 5 minus 2.6 is 2.4. When I square -4.8, I get 23.04. When I square 2.4, I get 5.76. And of course, I add them together for 28.8. This is starting to feel familiar. I add them together to get 28.8, and the square root of that is about 5.3. I already knew that my base yz was a square root of 80. We did that earlier. So fine, square root of 80 times my base times the square root of 28.8, my height. Don't forget to cut in half. Oh, look, we got 24 again. Are you having deja vu? You having deja vu? Hey guys, compare your three areas. What did we predict on question number 6? And was our prediction correct? Go ahead and hit pause. Just make a quick note and then hit play to keep going. Our prediction was correct. The areas are the same, no matter which side of the triangle I use as the base, right? I lost a T. The areas are the same. No matter which side of the triangle we use, it doesn't matter. And so you may have noticed some of these were a little easier than others, so choose wisely. Extra special bonus, we got one more on our Talk the Talk. Casey wants to paint an enlarged version of her company's triangular logo on the wall of the reception room for clients to see, right? When they first walk into the building, here's this big, beautiful logo. To get the proportions correct, she constructs a removable coordinate grid on the wall. She puts a big coordinate grid on the wall using tape and sets the intervals of each axis about 1 foot apart. And Casey marks the vertices of the logo at A06, R42, and T84 and connects the points with straight lines. So that's what I did. I drew them up here. So here's A, here's R, and here's T, and connected them up with straight lines. Get our pretty logo going on there. I want to go back to the red. So we said A was at 60. We said R, we did say 60, right? And we said that R was at 42, and we said that T was at, where was T? T is at 84. All right. Here's the deal. A 4-ounce bottle of the paint that Casey wants to use costs $12 and covers 8 square feet. She plans to use 3 coats of paint on the logo to really make the color stand out. And what I want you to do, did I do this right? Hang on, now Miss Scott's paranoid. Nope, Miss Scott did it wrong. All right. You know what, guys? We're going to call this one a wash because Miss Scott did it wrong, but it's more of the same stuff. If you feel like going for an extra challenge, working this out, sorry about that. Miss Scott made a mistake. She made a big mistake. Do you see it? The point A was in the wrong place, huh? Point A was in the wrong place. So point A, I'm going to clear all this off the screen. Point A should have been at 0.6. Point A should have been up here. Oh, no. And then point R was at 4.2, except I can't write very well. Come on, baby, where's my pen? Go back. Oh my goodness. Point at R was at 4.2, and then we said that point T, so there's point R. And we said T was at 8.4, and it was over here. So yeah, I did make a mistake when I did this, but here's your triangle. So if you feel up for a challenge and you want to figure out how much paint Casey's gonna need to do this, how much it's gonna cost her actually. If you wanna go the extra mile, figure out how much it's gonna cost her to do on paint, you are welcome to do that. But we'll consider this just an extra special challenge. If you're dying to know, then you can come talk to me about it in our breakout rooms. You can click the button and be like, Miss Scott, this is what I got. Is that right? And we can talk about it. But we'll just consider this an extra special bonus. So don't worry about the talk. Miss Scott made a mistake. I'm not going to torture you any longer. As always, guys, I know this was a lot, but it was a lot of old stuff that we put like all into one problem. It got intense. Whew. But you know how to do all these things. It's just a matter of getting them all in the right order and not messing things up, right? As always, guys, I hope you found this helpful and I hope you found this useful. If you got questions, let me know. I will help you. I'm only mildly evil after all. And I'll see you guys later. Bye.